Good morning, good afternoon, good evening. My name is Rhonda Student-Kaiser, and I'm the Director of Customer Engagement for BigFix. And I'll be hosting our BigFix Decoded webinar today, where we're going to be focusing on file delivery with BigFix and the fact that it is more than just downloads. We are recording today's webinar. If this presents you with any concerns, please drop at this time. You'll be able to access a recording of the event about an hour after we conclude. You'll simply follow the same link that you used to get here, and that will take you instead to the recording of the event. You can share that same link that you have with your colleagues who might not have been able to join. They'll be presented with a brief registration page, and then they'll be directed to the recording as well. We do encourage you to ask questions throughout the course of the event today. Simply add your question to the chat box and we'll either answer in the chat or we will feed your questions to the presenters at the appropriate time. So with that, let me tell you who we have today. So of course, me, Rhonda Student-Kaiser. We have John Talbert, our Director of BigFix Professional Services, Joe Saylor from our BigFix Accelerated Value Program, and Gary Lowe from our BigFix Professional Services team. So to dive in today, if you're familiar with BigFix, it's really easy to think of using BigFix and file downloads in the context of patching. And we do see a lot of questions in our customer community on the BigFix forum and the BigFix Slack on this particular use case. That said, there are several additional use cases that we have seen work successfully with our customers, and we want to take some time today to share those use cases and how you can elaborate them on them in your environment for your particular purposes. So with that, let me turn things over to Joe to introduce the 4 use cases we're going to be talking about today, and at the same time, I'll turn the presentation over to Gary.
Yeah, so we got a bit of a wild ride for you today. We actually have 4 use cases we're going to rotate through that all use separate parts of the product you may not be familiar with for delivering files to endpoints. We're going to start off with just some like very standard patch and software downloads through the prefetch command. We're going to move on to delivering files through site gathers, so not even using downloads from like a URL or anything, just straight out of the BigFix database. We will be taking a look at pulling data down from a CMDB and how you might use that in your environment, as well as dynamically generating files on the endpoints through pure ActionScript.
So as I'm thinking about the first use case and kind of the patching use case, for me, it's all about getting a known file down. And it might be a medium size or even a large size file, but it's a file that doesn't tend to change at all after release. And it's a predictable file that every endpoint's going to get the same one. And this is going to flow through BigFix. And Gary, I'll turn it over to you to lead us through how that flow happens.
Hey, John, thanks, certainly. I think the most obvious form of a download that we're going to encounter is going to be by way of a patch. And of course, within any patch fixlet, you're going to see within the action script itself a command that performs a prefetch of a known file with known attributes or properties related to that file, such as a checksum value or the size of the file, the location of the file, the name of the file, that kind of good stuff. These cumulative updates, of course, are rather large, as you can see by the size value over here, so I'm not going to demonstrate with that. So what I was thinking we might do is simulate that prefetch. I'm not so much interested in showing the actual install of the update, but focusing on the download. If I simulate something along those lines, let's see what happens through the infrastructure, starting at the root server, propagating down through the relays, and ultimately landing on that endpoint. So I'm going to begin with my first approach, or my first demonstration is going to be with pre-caching. So let's say I create the action right now, but I set the action to only begin tomorrow. I now have plenty of time to do a download of that update file or whatever file it may be, get it down onto the endpoint. It'll be pre-cached on that endpoint, and then of course ready to be used once the action itself executes. So let's go ahead with that. And the first thing we should see is that the file that is requested is downloaded by the root server and cached on the root server. Now, what is of interest to us, and so there we go, we do have this particular file that's downloaded and cached on the server itself. If I then go into Relay Diagnostics, which is one of our friendly tools, I can actually look at the download status on the root server and of course any other relay, provided that I have enabled this diagnostic feature. I just want to quickly go back to my console and refer to the action ID, which is 3881. And so when I look through my download status, what I'm really looking for is 3881, which is that specific action ID. And here I can see the details related to that file. I can see the name of the file. I can see the SHA-1 value of the file. I want that value. So if I take that value and I then go onto my root server, which happens to be this machine, if I go into this particular folder, which is the download path for the file that has been requested, and I list what's in this folder, and I search on that particular SHA value, I see that there it is. And of course, this machine is Pacific time, so that is the real time that the file got cached locally on the root server. So that's step number one. If I'm troubleshooting the download of this file, or I'm just curious and I want to know more about it, step one would be to locate the SHA value, the SHA-1 value of that file, and then let us traverse through the relays. So here's the next relay in my path. And once again, if I do a search on this action, there it is there. Once again, there's the details of this exactly the same file. And this machine happens to be a Linux machine, this relay. And so if I do a find, sorry, you can see I've been doing this a lot. The equivalent folder on this Linux relay happens to be right here. You can see the BF mirror, download SHA-1, and then
The one fun note about the SHA-1 folder that we keep looking at here is that there's a bit of durability built into this and a bit of utility built into the SHA-1 folder. You'll note that since we're in here and the file is named after its hash, not after anything to do with the action, then that's how the client first determines whether it owns the file. And so if you have, say, a single file that gets used across multiple fixlets, it will look at this folder first before it ever even asks its relay, right? So in that way, we can reuse downloads without having to do anything special inside your infrastructure. So long as the file is the same and the hash is the same, it'll get reused without ever having to talk to the internet or talk to its relay again.
That's a cool note. And so what if you've got two files that are the same and they're supposed to end up with different names, like you're using them for different reasons and you want them to have different names? How would we deal with that, right?
Yeah, I think Gary's got that, the secret to that in his example download fixlets, actually. So as a part of the prefetch command, you rename the file. So after the client sees that it owns it, after it sees that it has the file in this SHA-1 cache directory, you have already specified what it's going to be renamed to when the client goes to use that file.
yeah, sorry, I didn't catch the question. Thanks, Joe. But yeah.
And Gary,
So-
Gary, your mic is a little bit cool. Just try to raise the voice a little bit as you're talking.
Sure.
Thanks.
Okay, so performing the same kind of review on my relay, I can confirm that that file has now traversed from the root server down to the relay, or at least one of the relays in the path to that endpoint. So let us then see if the file has actually arrived on the endpoint. This happens to be the agent log, by the way, and you can see the action ID right there. This message right here, after doing a bunch of different types of testing, I thought initially that this wording meant that the file was not related to a staggered action. In other words, it's not distributed in relation to time. It's not a time distribution. And actually, that's exactly what this does mean. So sometimes if you create an action to multiple targets and you stagger those actions, instead of seeing the word non-distributed, you can see just the word distributed, but it's related to the time.
Nothing like live.
Can you hear my dog? I'm sorry.
Yeah, this is a great note to like take care of your security first. Your dog firewall needs to be turned on, and got to make sure that's done before we begin the broadcast.
Yes.
Sorry, give me one.
So yeah, I mean, fun note about language there, right? The non-distributed moniker there can mean multiple things because English is you know, kind of a garbage language. Shouldn't have two different meanings for the same word. But in this case, distributed is not distributed to your endpoints. It is distributed over time.
Sorry about that. They're outside laying fiber cable today of all days, and so my dog's reacting to them. Okay, so having said all of that, if I now go and look on this endpoint, I've got a number of different folders, so it's not that one, just bear with me. It's not that one. I believe it might be this one here. Okay, so this folder down here, you can recognize the action ID. I've mentioned it a few times, 3881. And you can see the path. It's under Base Data Global, Download, and then the name of the site from which the action was created, the action ID, and then within that folder, once the file has been downloaded and verified, you will see a file name with the checksum value for that file. And then within the name D folder, you'll see the actual file, right? So to Joe's point a little while ago, if I go back to my console, this is where we specify the name of the file. No matter what it is within the source URL folder, it just so happens to be the same, but it may not necessarily be the same. And then, of course, I do some manipulation of that file, whatever I need to do with it, when the action itself actually runs. So we just performed the prefetch to download the file, pre-cached it on the endpoint. What I want to do next is there are a number of different types of downloads, but I want to do something very similar. Slight difference here. We are using a prefetch block to list a number of files that we want to download. And there's actually a mixture of download commands that I'm executing. The first one is the prefetch that we've just been talking about. The second one is a no hash prefetch. And notice in the syntax, of a no-hash prefetch that you don't need to provide the checksum values or the size value. There is no real integrity checking in terms of this type of download, although we will see once I create this action that it's calculated dynamically, and so you do still track the file with the SHA-1 value as the name of the file. This
I really appreciate that your demo here is with the Notepad++ installer. Score one again for the most civilized of text editors.
Thank you. So in this case, I'm not going to make any changes to the action. It's going to download fully in preparation for the action to execute. So it's not going to sit in the pre-cache folder, and we're going to see what that looks like. What I was talking about earlier is if I was downloading to large numbers of machines, maybe over wide area networks or other slow links, I would want to stagger those times, and so the downloads wouldn't all occur at the same time. So let's create that. Now, one more time, new action 3802. If I'm sorry, got ahead of myself. I should wait for it to cache. Once I see that it has actually cached, and there we go. So 3 files. The first one is using the prefetch as we did before. The next 2 are using no hash prefetches. If I now go to my relay diagnostics page and I update or refresh this page, and now I search on 3882, which is right here, I will see my Notepad++ installer with this SHA value, and then I will also see the text files which in my action script did not specify the SHA-1 value. It still is calculated, and I still can see and follow the file using that SHA-1 value. The behavior through the download folder on the root server and the relays is going to be identical. I don't need to go back and re-show that. It's all the same. But what I hope to see is on the endpoint itself, if I go to this site, and I'm sorry, I keep getting ahead of myself. I'm not sure if it started the download on the endpoint, so my agent log would help me out. Actually, it's already completed on the endpoint. So using the agent log is always preferable if you can do so, because you see in real time what's happening, as opposed to waiting for the reports to traverse all the way back up through full DB and get updated so that you can see them in the console. So it's already moved through this pre-cache folder. It's not there, right? And so what I would expect to see is that, is this the right one? In the download folder here, there is the file that I want to use. I did not do anything with that particular file, but if we go back to my action, the 2 text files should now be moved into the temp folder, and there they are right there. You can tell by the timestamp. They just got moved into that folder. So that's how we would troubleshoot and follow the files end to end and ensure that they are in the appropriate folders on the endpoint.
Gary, does that technique hold true for files that change a lot? Like I think about Chrome, and they're updating all the time, right? And so having that no hash effect, is that of use here? And is there any consequence to that? I mean,
Okay, yeah, let me talk a little bit to that. I'm going to go onto this machine very quickly. So we already looked at this Windows patch fixlet, which did a prefetch. But if I contrast that with, let's say, this Linux um, update fixlet, it's actually not a fixlet, it's a task. But this task, which is doing I wouldn't call it a generic update, but it's doing a system-wide update. There's no specific package that's been targeted for the update. It's just implementing or orchestrating a system-wide update through the package manager. Now, if you look at this section right here specifically, uh, if you're familiar with some of these files, the names of these files never change. They are actually the repository metadata files. We need the repository metadata on the endpoint in order for us to do dependency resolution and such, and to validate that that package repository actually contains the files that we're looking for. So we always download the repository metadata. Now, we saw previously that even though there are no properties describing the checksums or the size of these files, we do still calculate the checksum when we do the download. The only consideration around this that you should be aware of, it would sound, based upon the description of what this does, is that, hey, why don't I create a policy action and do a system-wide update once a month using the same action? Well, the problem with that is the files that get downloaded using this no-hash prefetch are only downloaded once on the action. So when the action reruns next month in terms of the policy of the action, the endpoint is going to get the same files that it did the very first time that the action ran. And if the package repository has been updated, this metadata is going to be out of sync. And you're not going to see the results that you expect to see. So basically, do not use policy actions with this type of download. Ensure that you create new actions every time.
So
Is there,
Gary, oh, go ahead, John.
yeah, so looking back at the kind of the prefetch statements, there's a lot of pieces to it. Any shortcuts you can suggest to help us there?
Yeah, and actually, Joe was kind enough to share this with me, so thank you, Joe. Um, what I might do on any machine is create a folder, a temporary folder, for example, this folder right here. And let's assume these are files that I want to pre-cache on my root server or anywhere else for that matter, but I'm just using the root server as an example. And I want to use prefetch with these files. It can become laborious over time, especially with a larger number of files, to calculate the checksums for each of these files and then build out the prefetch statement for each of them. So one way to do this is, oh, I need to open this, and what, oh, I might be I'm on the right machine, am I? I'm on the wrong machine, I believe. Sorry, just bear with me 1 second. I should be on this machine. Oh, it's not maximized. That's the problem. That's what I'm looking for. Sorry, I ended up on the wrong RDP session. So Joe's given me a great example here, which is very useful. If you take this relevance and you can put it in an action, you can use it in Q&A, you can use it in any form that you want to. You can just adjust the folder names and part of the file names if you want to. And you can use that to do two things. You can see in here that it's calculating out the SHA-1 value and the size value and the SHA-256 value over here of each of the files in that folder. And it's basically generating those prefix statements for me. So I can now take any one of these or more, or all of them, and I can consume those as is. I can put that into a fixlet or into a custom action or into an XML file if I'm going to post the action. And it's all prepared for me. So that's one shortcut.
This is pretty cool because usually when I'm doing like the prefetch stuff, I'll just copy a prefetch and then I'll paste in the file name, the URL, and that way I get the format right. But if I've got a whole folder worth of stuff, man, I'm going to miss a paste somewhere and I'll end up with a broken thing. So this, and Joe, you wrote this one, I think.
Yeah,
I heard.
Yeah.
You're on mute, Joe, but that's good because we like being on mute.
Yeah, honestly, this has been a problem that everybody has had and has been solved an embarrassing number of times. If you just like troll the internet for half a second, you will find 40 different versions of this. You'll find like Python scripts, you'll find PowerShell scripts. I think it was Mark Green made a make prefetch.py script that will just use a URL. Like you feed it a URL and it will do the same thing, and then so you don't even really need to modify anything afterwards. So there's many easy ways to do it. Don't do it manually. Like there's tools.
Hey, before we move on, I just wanted to mention one thing. There is a wizard which actually will assist you with pre-caching relays. It's actually this wizard right here. A couple things about it. When you do select ultimately the fixlet that you want to use for the file, once you've selected the fixlet that you want to generate the pre-caching for, it only works with prefetches, right? So if I have a fixlet in here, and I'm just looking for the right one. So this one has got a download command, right? There's no prefetch in this fixlet. If I select that, it's going to tell me that there's nothing to do because it doesn't support the download action command. So you can only use it with fixlets that contain prefetches. And the design behind this is it creates an action that targets the relays themselves. When the action runs on the relay agent, of course, that agent downloads the files. The files are then moved into the relay cache, and then they delete it from the endpoint folders. So that's basically how that works.
So this is a pretty comprehensive look at just what prefetch does and how it brings files down to the endpoints. One other interesting thing with prefetch is we actually have a separate channel for, it's essentially the same. It operates the exact same way that we've just looked at. It's called the utility cache. So it does all the same stuff. It verifies hashes, sends files down to the endpoint. The server pre-caches the file before endpoints ever ask for it. So all the same great security stuff, only it's a separate pool of files. That's really handy to just keep in mind. It's not super well known, uh, and it will, like, the main advantage is that anything you use this utility command to download with rather than prefetch does not get pushed out by other downloads. So meaning you can have a tool that you want to live on your endpoints forever. And if you download like a 6 GB Microsoft image to your endpoint in the download folder, it doesn't get, your utility does not get pushed out. So it'll just live there forever. It's really handy to use for like at many of my other customers, they will have like a uh, like custom executable that has notifications built into it. So something that's well branded for their company, that everybody in their company knows and understands and trusts, and they'll use that to pop up notifications inside Fixlets and use the utility cache to keep it there all the time, so we're never waiting on it to download.
Yeah, yeah.
Great
Thanks,
point
Joe.
about
But actually, in that previous action that I had created, sorry, John, in that previous action that I had created where we looked at the two files that I moved into the temp folder, I actually did incorporate this utility command. And once again, on the endpoint, slightly different folder location, but there is this utilities folder. And within that utilities folder is the copy of my Notepad++ executable, which is now available for future reuse. Assuming that wasn't an application installer, assuming that was some real utility executable, it would be there for future consumption.
So before we move off the typical download, there is a question I wanted to bring forward, and then we should probably move on to the next piece. And that the question is, rather than avoiding prefetch no hash in policy actions, what's wrong with using download now, instead grabbing a fresh file every time, other than bandwidth concerns? So
Sorry.
one piece there is download now is deprecated, so I don't know if it's going to stick around forever. Gary, you had a thought?
Yeah, so I had only mentioned download, which is a specific action command, which still does use the infrastructure. The download now, the difference with that is that it bypasses the relay infrastructure and goes directly to the source. So obviously it needs access to the source. And if it is deprecated, of course, there are now download direct capabilities, which are enabled by way of various different client settings. And so you can create an action and go out and adjust or add or remove the appropriate settings to either enable or disable download direct. It actually is functional both at the relay level, so you can have the relay go and download direct, but the endpoint still gathers it from the relay as normal, or you can have the client itself go direct. And that is probably in the case of a work from home user or something along those lines, where maybe your VPN bandwidth is a bit constrained.
So if that covers our prefetch questions, how about we move on to use case number 2 here? So so far we've talked about really big files coming down to individual endpoints that are all common, and you want to be sure that it's a single large, like, installer type file going down to your endpoints. But how about you have like some piece of data that you need all of your endpoints to have, that's common, not particularly sensitive, and say you want to update it all the time. Um, this is like, consider maybe you have a subnet map where you have like 5 or 6 different physical locations, and you know which subnets belong to each of those locations, but you have to get down to your clients somehow the data to tell where they live, right? You want to know You want that map to go down to your endpoints. You have to update it frequently. Say you have virtual infrastructure that frequently adds like new subnets, and there's only maybe a couple of boxes on each subnet, right? So we got this frequently changing data set, not super sensitive, and you got to update it all the time. We're going to talk about deploying that with a site file. So, completely ignoring the whole prefetch strategy and pushing files down through a site.
Yeah, absolutely. So let's take this as an example. I have data that is pertinent in one way to all my machines, but for each machine, there's also unique data in this file. So the first consideration would be, well, you know what? I want this file on every machine, and then I can always consume the data for the machine. I can do a search by MAC address or by host name or IP address or some other property, and I can find the row for that machine and consume it in some way. And I'm deliberately talking about this because that's going to lead into something down the road. But let's say I've got this file and I want an easy mechanism to distribute that file to either all endpoints or a specific group of endpoints. As Joe mentioned, if you look at any site, custom site, because you need write access to it, or an operator site, one of the nodes is this files node. And we can actually leverage that to select the file that I want to distribute. And then if I do choose this option here, it will actually propagate that file out to the machines. So we're in this demo content folder. I want to quickly go to that folder, and I forget which one I was in. It wasn't that one, so let's get there. It would be in this one here. And I want to make sure that this specific file is not already on this machine. And no, it's not. Okay, so this particular file is not currently on this machine. So let's add that file in. And what we should see is this file that was added to the site get gathered and arrive on the endpoint in this particular custom folder, and there it is right there. So now I've used that mechanism to distribute this file to every single machine that's subscribed to that site. So a one-time add as a site file, every machine that's subscribed will receive that file.
So Gary, one of the really tricky parts about this that isn't maybe super well documented is how you then access those files. So it's on every endpoint right now. How do I talk to it in relevance? Like what does a property look like that accesses that CSV?
The file itself, of course, is accessible by the agent, right? So a good use case would be with a comma delimited file like I have shown right here, and then either with an analysis property or a retrieve property, I can then query that file. As I mentioned earlier, I might have a file with a lot of with information for a number of different machines or data that was sourced outside of BigFix, right? So somebody provided this information to me. I've taken that information, created this comma delimited file, and I've distributed it out through to every endpoint. I can now use a retrieve property or an analysis property to return those values with this appropriate property names, so I can then consume them in some form or another.
And can you show us the relevance of one of those properties?
Yeah, so actually, let me do it this way. A comma delimited file is actually propagated out through our ServiceNow integration. It's not propagated out as a site file. Notice there are no site files here, right? However, the properties of the analysis that's created does consume that string. And you can see we're looking at specific fields within the string that are comma delimited. So item 0, then item 1, then item 2, and so on. And we need to point to the name of the comma delimited file that was propagated out. And then, of course, we do also have to identify where that file resides. And notice, in this case, it's not in a site or a custom site, it's in a mailbox site, which is a segue into another part of the discussion. But basically, this is an example of the relevance that you would use to access the data that's propagated out either in a site file or in a mailbox file.
Awesome.
There have been a couple of questions that came in that I think are referencing here that I wanted to just hit very quickly. One of them was about the kind of the sensitivity of data that we're sending around with the site file idea, and that this mailbox technique actually doesn't send all the data to all the endpoints. It sends the specific data to the specific endpoint. So that's a method for kind of getting around that broadcast of maybe semi-sensitive data like subnet masks and things of that nature.
Yeah, and I'm sorry, John. I think you were referring to mailbox sites, right, as the more secure method, and having specific
Yes.
data on the machine, right? Yes. So as I said earlier, that indeed is how our ServiceNow integration product works. The product itself gathers data from ServiceNow, gathers data from BigFix, the BF Enterprise database. It does the correlation. It separates the data by matching CI record to computer within BigFix. And then it extracts data that's unique to a given machine, and it propagates a mailbox file containing only the data that's relevant to that specific machine.
There's one other question I thought was interesting in this context, and that is about encrypting the file. And I think that goes back to the idea of it might be a little bit sensitive in there. And I think from my point of view, I think that if we're talking about super sensitive files, we probably want to use secure parameters to get the stuff down. We do that technique with some of like the SQL CIS controls, where you need to have a password to get in to check the settings that we want to check, and getting that password to the endpoint securely is actually quite hard, but Mailbox does that. And it sends basically an encrypted file and then encrypts the decryption key and sends each decryption key to each endpoint individually in order for them to decrypt their particular copy. And that's all we've got for the questions that I thought that were well aligned with where we were.
Okay. I don't know how we're doing time-wise, but there are two other things I I think
Yeah,
we can
let's
cover
I
quickly.
think well, we kind of dived into the whole mailbox topic, which was our third topic already. And really this is, the idea that we want to have something that's very specific to an endpoint. So in the case of ServiceNow, perhaps that there are owners or computer groups or divisions within the company, things like that, that you want to base on ownership values that are in CMDB. And it's very, very important that in the ServiceNow CMDB, or I think you can use a similar function via API, but sending something that is a high correlation value from one one system about one endpoint that you want to be absolutely 100% certain shows up on only the matching endpoint. And that's where mailboxes come into account, because it's very much, if it's a very strict correlation, that value won't go to any other machine but the machine that it's correlated to based on the computer ID. So I think we kind of really talked about that already, but is there anything else we want to focus on there, or maybe we've done enough?
I just wanted to show quickly how you would use the API to
Okay.
manage files. Um, and I also, so let me do that quickly, right? So first of all, I have two very simple scripts. One will use APIs to extract the current mailbox files from BigFix, as I said, through an API. That will in turn, give you details about those files, who has them and what those files are. It will also allow you to then go and delete those files from specific machines if you wanted to do so. And then I have another simple script is, hey, what happens if I want to distribute my own box files? What would that API call look like? So they are both fairly simple. If I quickly run this one, you see that response okay. That's actually a login. So there's multiple REST API calls in that script. The first one was the login, which shows that my authentication is successful. And then I generated by computer ID a unique file from each computer. And if I look at those, for example, this one right here, I quickly look at that. I can see the details. I've got that computer ID, I've got the actual file ID. Then, of course, I've got the name of the file, the ID of the file, the SHA-1 value of the file, the size of the file, etc., etc. And if I quickly expose the script, you could also, by specifying in the URL the ID of the computer and the ID of the file, perform a delete. And so then you can clean them up. Conversely, if I actually want to post a file out, once again, there's going to be a login. You can save it to the token to a file and reuse that token for future API calls. But this is the actual, you need some headers, specific headers. You need to identify the CSV file. And then, of course, you need to identify the computer IDs of the computers that you want to deliver this file to. So you would have to enhance the script, maybe feed input using variables within the file, but you can automate this with a little further work on it. But I just wanted to quickly show. So in this case, I am deploying out this particular file, and these are the details for that specific file that's being deployed. The endpoint ID, the new file ID, the the SHA value, etc., for that file. And then, of course, if I go onto the machine and look in the mailbox site folder, what I hope to see in here somewhere is this file, which is the file that I specified right here, right? That one there. That file has now been delivered. I can see the current timestamp of that file. And this file should contain only data that might be relevant to this particular machine, right? So it's one row of data for this machine. The other thing I wanted to quickly segue into was, only because we were running out of time, earlier on, Joe had made mention of quote unquote delivering files to endpoints, but not really sending a file to an endpoint. We have ways in which we can generate files dynamically on that endpoint. There are two action commands. One is append file, and the other one is create file. But the nice thing about this is I can use relevance in that append file. So earlier on, I showed this full CSV file that had multiple lines of data in it, which is this one here. So it's got multiple lines of data in it. What happens if I just want to extract one row of data from that file that's pertinent to this particular machine, which I'm going to identify or match by MAC address, and put that into a new file, right? So put it into this filtered file. That filtered file will now only have the data pertinent to this one machine, and then I can consume that data in any way that I need to.
So one of the main use cases I see for this just out in the wild in general is kind of a reverse data flow. So in this way, using append file and relevant substitution, you have access to everything that the client has access to. So that's, registry data, that's maybe Active Directory group data, stuff like even antivirus definition files. And so all of that combines to a really good picture of the security posture of your client. And so what I often see is customers will use just like a bunch of append file commands to gather all of this data and throw it into a central document, just like a single text file that's machine readable. Uh, it will then exist on every machine and has access to all this rich data. So it can then be consumed by some other application that maybe enforces your security posture, right? Like maybe something else turns off or turns on the firewall on the endpoint and blocks it off from everything else, right? So now we can show our compliance state to other applications and feed data up in this way.
Great point, yeah.
All right. I think we are getting close to the end of our time today. Any last items we wanted to cover before we adjourn? Or any other questions, John, that have come in to the queue?
There have been a couple of comments and questions have come in around the whole data security piece, especially when we're talking about, well, we started with, of course, download of non-sensitive files that don't change, and that's the normal download prefetch. Download now was talked about a little bit. We talked about the kind of a little bit more dynamic and maybe smaller bits of data, maybe things that we want to have available that might change over time, and using sites to get there. Likewise, using mailbox site, and basically instead of broadcasting a wide piece of data, broadcast or unicast a narrow piece of data directly to the endpoint to help reduce attack surface there. And then finally, dynamically building the actual file on the endpoint using things that are on the endpoint already as being techniques. But in that second technique, I think it really led to a bunch of questions around, well, how can we secure that? And the answer is, you can take countermeasures. Like the mailbox thing is a next layer down thing. Now, if a box is compromised and becomes in the wild and somebody gets admin on that box, they own the box. All the data on that box is going to be subject to being cracked open one way or the other, whether it's using techniques that are available at the OS level or even using a tunneling microscope to read the bits off of the disk and then running it through AI or next level decryption and spending millions or billions of dollars. Getting data out, if it's present, is always going to be possible. You just want to make it resistant enough so that the data is no longer valuable by the time somebody can get to it.
Yeah, the security layers are really interesting to analyze. In all of the techniques we've talked about so far, uh, the endpoint itself is not encrypted, right? So once the file lands on the endpoint, then in all of these techniques, it's visible and readable. And if someone owns the box, there's not much you can do about it. When you get to mailboxing, that's kind of the only method that we've talked about so far that adds significant additional security, where the file is protected the entire time until it gets to the endpoint. So the file itself is encrypted in addition to whatever communications encryptions you have enabled, like relay authentication, right? So that does provide an extra layer of security when the data is in flight. The thing that I think John mentioned earlier that actually secures the data all the way down to the endpoint is secure parameters. So if you have a small bit of data, like very small, like a single string of text, secure parameters are how you can land it on the endpoint without anything ever being able to see it, unless of course you write that data somewhere else, in the course of your action. But it won't ever be visible, like even to an attacker, just in the standard course of delivering whatever that data is.
Excellent. Thank you, Joe. All right. Well, thank you all for joining us today. The recording of this event will be available in about an hour. Again, just follow the registration link or the join link that you have for this event, and you'll be able to access that recording. Thank you, Gary, for the very thoughtful demo content that you provided today, and Joe and John for helping us to set the stage and to continue the flow and make it make sense. Really appreciate that. There is a post-event survey. We do appreciate your inputs there, and we'll be meeting again in our BigFix Decoded series on August 28th. So that'll be the next time you'll see us. We will have the BigFix Briefing Room available on our YouTube channels the Wednesday after Patch Tuesday. I guess that's going to be the 14th or so. So looking forward to spending more time with you all in the future, and thank you all for joining us today. Have a wonderful rest of your day.